Thank you very much. I'd just like to give you a run through on TransGrid's asset renewal program. Take that through at a fairly high level. There are a number of elements at different levels, both at the substation, line and component level. I don't have time in the slot available for me today to go into individual projects. I am happy to do that either outside in the break or in a separate meeting with anyone who wants to go through any individual components or any individual projects in itself. But what I'll do is take you through the actual process that we've put together. So our asset management system, on which everything is based. So TransGrid developed its asset management system back in the 90s, built on the need to have the requirement of the then government and departments to have a total asset management program within TransGrid. It was a bespoke system. There was no standards available. We just followed the guideline and developed that. But since that time, asset management has evolved as a discipline. And while it was the traditional thought was that asset management encompassed the utilisation phase, managing the assets within that, the discipline now encompasses everything over the full life cycle, that is from conception, development, through the utilisation phase, which is usually the longest, and then through renewal and disposal. And there's been a number of, and as part of that evolution of the discipline, there's been a number of standards that have been developed. The first one that came out in the UK was PAS 55, and that was built around the requirement of the regulator for a consistency in the regulation of electricity and water utilities in the UK. And it's a standard that is built around alignment, so taking everything from what's in your corporate plan, building asset strategies, setting measurable objectives, devolving those into plans and then executing them. And the concept of alignment, so knowing why the person on the tools, why then when they're executing a job, knowing exactly how that relates to the corporate plan. Standard has, that publicly available standard, PAS 55, then moved out through Europe into other parts of the world, and with a demand for an international standard, ISO 55000 series is now being out there and is able to be used by the organisations. It was released early this year. So TransGrid has been transforming its asset management system to take in the full life cycle. We've been through a pre-certification process earlier this year to both PAS 55 and ISO 55000, and we've made a decision based, having looked at other organisations throughout the world and in Australia, how they've used these systems, how they've derived value, how they've got consistency, to go for certification in November this year. So our asset renewals are built around our asset management system. It's also worth noting, as we've gone through this process, we've been building our knowledge and our skills in the cost-risk service trade-off area. We've developed some tools. We've got a way to go in terms of that roadmap, but in all circumstances we can see where there are trade-offs to be made. And not all of those trade-offs actually get contained within our organisation. So if there's a change in cost, it can actually translate to movements of risk to others, between our organisation and others, or changes in service levels. So it's important that we understand those particular issues, and I'll talk more about that in some of the projects we have. All of our asset renewals are based on condition. People say it's where does age come into it? Well, age is just one indicator we use in terms of the asset. Clearly, an older asset is more likely to have issues than a younger asset, but it's not the full story. There are things such as the environment in which it's deployed, its initial design, how it factors into reliability and its criticality, how it's being utilised. There are other factors we look at. We look at its maintenance history, its defects and its service performance. And we put those together in order to build a particular indicator of where we might look for further condition information. But we then move to a full, when we have a list we then of areas where we need to look at. We then undertake a specific condition assessment, either on the individual component, if it's a circuit breaker or a CT, or on the whole asset, if it's a whole of asset, if it's a substation or a line asset. So age is not the factor on which we're looking. It is just an indicator to point us in the direction of doing a full-scale condition assessment. Once we've identified, if the asset is identified and we do the condition assessment, from that we can extract what needs to be done. So we work through a structured process of option identification to address the need. So it depends on the scale of the issue as to whether it's a wholesale renewal, whether it's a targeted renewal, or whether it's just a component type program of replacement. Options are scoped, they're costed, and we do an economic evaluation to select the most efficient and feasible option. That also ensures that we are clear on how we would deliver that option and the risks that may be faced in the delivery, which is a significant risk to both the service and other customers who take supply from that point. In circumstances given in today's environment, there are options to look for lower cost alternatives to replacement, and that includes changes to network configuration and the potential to use lower rated equipment. And the LIN, that usually goes across to the LIN, and I believe he's going to talk about at least one of those in his talk after mine. So on transmission lines, they generally fall into two categories. In the load corridor area between Newcastle, Sydney and Wollongong, which is where most of the load is, we have a large number of steel tower lines. These were developed in the 60s and 70s as the electrification of New South Wales expanded from 132 kV to 330 kV. They're in, most of these lines, particularly those very close to the coast, are in a corrosive environment, salt-laden air, and have been there for about 50 years. And we have to make a decision as to whether we undertake renewals on those particular structures. The conductor is in adequate condition at the moment. Insulators are being dealt with on a case-by-case basis. But the structure itself, what do we do about the particular structure? Do we just allow it to go through to its full life cycle, or do we look for an extension of life? In this particular case, we've looked at the range of options from do nothing to full-scale renewal through painting and life extension. And what we believe is the right decision at this time is to only renew, and that is to remove the corrosion and paint the high-value structures, which are the tension structures, which we can't readily replace. We have to take the line out of service, so therefore by doing that, we remove a risk that there will be an extended outage on a range of lines. And also on those suspension structures where we wouldn't be able to do a replacement at the side of that particular structure, so another high value structure. All the other suspension structures, we will defer doing any significant work. We will do minor fastener upgrades and any other member replacements, but we will allow them to have their standard life cycle. By doing this, we believe that this defers a significant amount of expenditure. It allows us to be in a position to understand in the future whether that line will need to be retained in its current form or some other form, as there's a good degree of uncertainty in where the load is forecast to go in the future. And this, we're talking 15, 20 years ahead. But if the line is retained, then by maintaining the structural integrity of those high value, difficult to replace structures, we can do a further targeted renewal on that line without having extensive outages and impacting on the market. So that's our steel tower corrosion proposal. There is no change in the rating of the line. The line will still be there. We will manage the outages in such a way as not to impact excessively on the market. And so we believe that's a manageable process of work. We also have a lot of aged wood pole lines in inland areas. Some of those being particularly old, have suffered a loss of strength in the wood poles, and we found this out through some events. We also know that we've had a significant termite infestation in some of these lines, and and some of these lines were delayed from being replaced. because we believed that if in the previous regulatory cycles, that if load growth had continued, those line routes would be reutilised at a higher voltage. That load growth hasn't eventuated. The need to reuse the line route hasn't eventuated. So these lines now need significant renewal works. And our process for this is to replace the H pole, 2 wood pole structures, with a single concrete pole or single steel pole structure, whatever is the most economic, as long as it's homogeneous along the whole line. So that's our transmission line strategy. Again, we're not intending to change the conductor. We're intending the conductor's in good condition, and we intend to continue to use that conductor. So that's a low-cost renewal. In substations, in the large scale of things, we've looked at a range of indicators that are used at each site to rank those sites. Age, as I said, maintenance history, defects, replacements that have already occurred at that site as another thing. And each individual site is assessed for its primary plant, civil works and structures, and its secondary systems. And we're also conscious on developing options that only address the need, that take into account the community expectations, and the community expectations is that we will generally stay close to or within the boundaries of the existing sites. They don't want to see us expand our infrastructure, even though a lot of the time, in some locations, they tend to be in particularly rural areas close to towns, which have now expanded. So there is a need to look what we can do within the footprint as a deliverable option. And we also take into account future and existing requirements in terms of what we think assess maybe option value that we need to maintain, so in terms of future connections that may be needed at that site and how we can get there. And the technology path for secondary systems, because many of these locations come back to the days when click-clack relays, analogue relays were in place, and how can we extract some value by replacing those with modern systems. We looked at the benefits of doing a range of solutions, coming from full-scale rebuilds down to targeted renewals. It's come down to the majority of the renewals end up being targeted renewals of particular items at that particular site. There are very few where we've actually gone for a full rescale rebuild in the end. Secondary systems. We have a mix of technologies across all of our sites, across all of the systems. We have analogues, the old click-clacks, which are fairly old, difficult to maintain, and there's a loss of expertise out there. Electronic, made up of discrete components. We find that the components drift, and so there's the suitability of the particular relay and control system. And microprocessor, where they're great when you get them, but the manufacturers like to evolve technology fairly quickly, and we lose support relatively quickly in terms of life cycle. So you go from the analogues, which had a fairly long life, to the microprocessor, where the turnover can be 10 to 15 years in where support is lost. And it's loss of product support, which is the primary driver across the range now for looking for ways to, and loss of product support and the ability to maintain them effectively is the primary driver for renewals in this area. We've held back in the last revenue determination, looking for the best way to deploy secondary systems renewal. It's a common problem across the industry. To find ways of secondary system renewal, because the turnover is much faster than the primary systems because of their life cycle of the newer equipment tends to be in the 10 to 15 year phase before you have to look for a suitable renewal program. We're looking to transition to IEC 61850. We have a development team at the moment looking at how we can make that happen and do some trials on the smaller sites. And we believe we'll be doing that within the next 1 to 2 years. And you will see then a move from a copper-based wire of wires throughout your substation with specialist technicians who have to look at each individual relay or control system to a fibre-based deployment, and where it will be more run as an IT system. So that's probably 5 to 10 years away before you get that full benefit, but that's where we're setting ourselves up to do that. In the meantime, we're looking at targeted renewals at each of the sites we're looking at, based on each site's needs. And that includes, so it depends on what's particularly the site issue. In some of our older sites, particularly the ones that are 40 and 50 years old, the deterioration by vermin of the actual cabling in the switch yard is a particular concern. And the cabling is a particular key decision. Having to replace the cabling drives you to a solution which usually is the modular control room solution. If your cabling is fine and has plenty of available life to match the equipment you're going to put in, then a solution within the existing control room is probably the most cost-effective solution in the short term. We're also looking at some sites to doing some very low-cost technology upgrades to allow us to take advantage of the intelligent electronic devices that are there. It's much the same as if you could think of it in terms of your smartphone. It's a phone, but it's got a whole lot of other things. And if you can actually access those, such as the ability to know what, remotely interrogate the relay and get the relay flagging back, you can actually make some intelligent decisions quicker in responding to events. So we have some low-cost technology upgrades which we're also deploying as well. So we've got a balance of those sort of things happening, but we're really setting ourselves up for 5 years beyond that where we can fully deploy an IEC 60850 solution. My team has developed an extensive documentation set in terms of the revenue proposal, and I do mean extensive, and there's probably 800 documents sitting there. We've taken those documents through a number of review processes, the assurance review, quality reviews. I'm happy to talk. I've got full asset management system documentation. There's such a large range of things we could go through, but I don't have a time frame. I'm happy to take offline anyone through any particular project they want to go through, or any sequences of projects or any of our systems to if they feel comfortable, just come and see me in the break and we'll arrange a time to do that. Okay.